Hey, Travis. Long time no see.
All right. Hello, everybody, and welcome to the stream. Taman, thank you so much for the sub. I really appreciate that. The Prime, 15 months. That's awesome. I really appreciate the support. How have you been? It has been a while. Hope you're doing all right. I was just actually talking about you the other day on stream, indirectly, anyways. Magette's good to see you as well. All right. Yeah, it's been a few months, I feel like, at least. Yeah. Life gets in the way, though. I do get that. All right. So we're going to pick up where we left off on the last stream. Before I jump into that, though, because we do have a couple of updates that have been made off stream, hints of those are on the screen here. I do just want to take a quick second to thank the supporters of the channel, like Taman there. Starting with our elite partner, Javier Lazaron, followed by our partners, Gabolis Inc. and Matt Osgard. This is a list of the people in the highest tiers of subscription over on Patreon and YouTube memberships, followed by the other supporters you see here listed on the screen. They're a combination of the other tiers of support over on YouTube memberships and Patreon. So thank you all very much for the support. It greatly helps me in things like covering the costs of subscription fees, software licenses, hosting fees, that kind of thing. So it's definitely very much appreciated. Thank you all for that support. And Taman, it's on that list, or at least he will be on the next episode because it hasn't updated yet. But I would also be making a mistake if I didn't give a big thank you to all the viewers, whether you're catching this live either on the YouTube side or the Twitch side, or if you're just catching the VOD after the fact. Thank you very much for being here. I appreciate each and every one of you guys. Without you guys, this channel and this project would not exist. So thank you guys very much for being here. Let's see. Last time I was here, you were doing the item editor. Yeah, it has been a bit then. So yeah, supporters are now rolling on the screen. I just figured that was a little bit better of a way to do it. Because I was always having to change like the font size to list them out the way that I did before. So it just, I think, flows a little bit smoother to have them scroll on the screen. If you tilt it, it'll turn into a Star Wars intro. I mean, I suppose I could do that. So yes, the project. Goodness, what have we done since then? Quite a lot of things. We've done quite a lot of refactoring and simplification in our game code, or at least in the engine for our game code, right? Because there were a lot of things that we were doing that were just kind of cumbersome and clunky and weren't very easy to use. And there were some things that we frankly didn't really need in terms of complexity and overhead. So we actually did a whole bunch of stuff in the previous release, which would have been down here 0.10. So we did a bunch of refactoring in terms of things like the renderer, hot reloading, asynchronous / jobified asset loading. We reworked our import pipeline to be external to the engine. We redid the asset system and the resource system. We got rid of the resource system, rather. So that was a bunch of stuff that we did in the last version. And in this version, we are actually pushing for a bunch of things. So we've already done a lot of work here too. So we've removed the render graph completely. The render graph is one of those experiments where it was cool, it worked, it was super flexible, but there's a lot of overhead and complexity with that we just frankly didn't need. And so we've switched over to using what we call a bespoke application renderer, or a game side renderer, because the game understands what all needs to be rendered. Things like context, like what order it needs to be rendered, how it needs to be rendered, what properties it needs, things like that. Those are all fairly game-specific problems. And so, we kind of decided, we're like, you know what, why don't we treat the renderer front end as more of a library, and really offset the actual control of how that renderer does its stuff to the application where it belongs in the first place. So we removed the render graph and replaced it with a brand new game-specific renderer, right, or application-specific renderer. So that's already done. And then the second phase of that is going to be, we're going to do the same thing for scenes, because scenes are highly game-specific. Depending on the type of game you're making, your requirements for the scene and how its data is queried, things like that, how that data needs to be represented, those things are going to vary widely depending on what your requirements are. So that is actually next on the roster, and probably what we're going to be doing tonight. However, I also kind of made the call that our handles, our K handles that we had, were kind of large and kind of unnecessary also. So I've begun switching systems away from using them as well. And some of those systems, while I was in there, I kind of renamed them as well to make them a little bit more consistent with the rest of the code base, right? So I'm trying to aim more towards consistency and simplicity across the code base. So, for example, the Xform system that we had, the naming of that was always going to be temporary, right? But that has been renamed from Xform to K-transform, right? So that's how those are represented now. And instead of K handles, we represent those by a type-deft U32, in this case, called a K-transform. So if we actually look up what a K-transform is, it's a U32. So let's see, do I have... let's see. So we have a K-transform here. Oops. And so you can see here, all it is a U32, right? So the idea is this is basically just an index into...
Hope all's going well.
Oh, Diamon. It has been a while. You and Tammin both in one night. That's awesome. Thank you so much for the tier 1 sub. 21 months. That's awesome. Thank you so much for the support. All is definitely going well here. I hope it is for you as well. What are you up to these days? I was just kind of catching up Tammin and the rest of the stream really on what we're doing, right? Or what updates have happened. So one of the things that we were just discussing is I replaced the Xform system with a K-transform system, which basically kind of does the same thing. It's a bit of a rename, but we also slimmed down the code a little bit, right? So instead of having these handles that get passed all over the place and it being a little bit weird as to, what's this K handle for versus this one, we now have a U32, in this case, K transform, right? And so we did that for the Xform system. The hierarchy graph is the same concept. In that case, I wrote here I used U16s, but I don't actually know if I used U16s. Did I? No, I used U32s. That's actually wrong in here. U32s. Some systems I use U32s, some systems I use U16s. And it's up to the system as to what that is. But since it's type deft, it'll never matter to external code because you can swap that out easily. So the hierarchy graph was changed in the same manner. Instead of using handles everywhere that have both the U64 and a U32 in them, those are just represented by a single U32 now. The audio system received this update too. So it's represented by U16s, again, type deft. Same thing for the timeline system, same thing for the renderer backend. So the Vulkan backend now just uses this instead of handles. So that's a lot leaner as well. The material system as well was received that change. It also got renamed from material system to K material system just to make it a little bit more consistent. And I also did this with the shader system. So a lot of these things, I think some of these things we might have looked at on stream last time, but most of these things were things that were done offline. So I just kind of wanted to go over those things really quickly, just so that you guys have an idea of where we're at. And so all of these changes have been made to our Illumina code base. And we do eventually need to go back and update testbed and probably the overdrive code base as well. But I've basically just turned compilation for those off for now so that we don't have to worry about it. And we'll go back and do those things. I'll probably do those off camera. So we're essentially going to use Illumina's code base as sort of the template for the other two. And then we'll go from there. Let's see. Let me catch up with chats. Got laid off, had to find jobs, decided to take a sabbatical instead, and here I am. Well, yeah, man, I'm sorry to hear that. And that being said, I really appreciate the support. You definitely don't have to be doing that. But yeah, I got laid off last year as well. So yeah, I do understand that pain. I've been there. It's not a great place to be in. Makes you feel kind of poopy, to say the least. So I'm sorry to hear that, and I hope you find something soon. But the sabbatical's not a bad idea. I could use one of those myself, frankly. Let's see. That's cool. I also use system-specific handles that could be different sizes as needed. Yeah, and that's what I was thinking, right? Because like not every system needs a U32. Some of them don't even need a U16, frankly. But if you type def it that way, you can just kind of switch the system very easily around it if you needed to expand it for some reason. The U32s or U64s that are bitcast pack structs that have some extra info in them. And I've thought about doing that too. And the cool part about type defing them like this is if I decide to do that, I could just change this to a U64 and bake that extra info in here. And nothing else outside this would be the wiser. So yeah, it's definitely the way to go. For example, my image texture index is U64 with a U16 for the index into the texture system, and the remaining encodes the height, width channels and stuff. When you need texture image with height, you don't have to look up an array. Ooh, that's an interesting idea. I'm actually thinking I could probably bake in the renderer backend representation of the texture that way. Because my front end and back end are separated because of render APIs changing on the renderer backend, and how those are represented internally. But I could probably do something similar to that. Not first, but here I am, brother. I appreciate you, Spiro. How's it going, man? Good to see you. I'll mostly be lurking tonight because I'm working on the second half. Wait. I'm working on the second half of the monitor. Oh, okay. That's fair enough, Tammin. I appreciate you being here, though. There's a silver lining. The company I was working for is not doing well at all and poised for an even bigger layoff. At least I got a good severance. Well, yeah, okay. That's fair enough, Diamond. Can't argue with that. Your wife's first reaction to you telling her you got laid off was thank God. Man, that must have been a really bad situation then. I've been there too, although I didn't get laid off for that place. I ran for the hills from it, but yeah, that's interesting. Well, I'm glad you're out of that situation. Unfortunately, not under better circumstances, but hopefully you'll find something soon. All the best. All the best wishes for sure. Is that E. Hamza over on the YouTube side? Hello? I'm not sure if I'm reading that right. Or is it Lee Hamza? I can't tell. YouTube's font choice is terrible for that because capital I's and lowercase L's look the same. And Tiki Quino, hello as well. I'm not sure I pronounced that right either. I butcher names all the time, so sorry about that. But welcome. I hope you're doing all right. You're chilling? Good, Diamond. Good. Glad to hear it. Okay, so now we're going to talk about what we're going to do tonight and tomorrow night and maybe even beyond that. Because I really want to get into a discussion on how we're going to handle this scene business, right? Because we want to handle it in a much less generic way. And I know that sounds weird because most people will tell you, oh, generic logic is better, right? But in this case, like it's really not, right? And that's kind of what we discovered with our current scene system. So we actually want to go less generic and more targeted to the data that we're actually dealing with. That way we can actually lay it out better in memory for how it's actually going to be queried and used. And so we're going to think about that a little bit tonight. And then also some of the things that we need to do to get there. And this is the last big effort that we have to do in terms of the refactor. Before I go any further, though, I do want to show you guys that this does actually run at the moment. So we are actually back to a working state, which is good, right? So I can still, do all the things that I needed to do, gameplay wise, right? We don't have much of that stuff in here yet, but that stuff's coming. So, just as a sanity check, like after all of these refactorings I've done, everything does work, even though it's much, much lighter, right? All right, so there's a couple things that we need to do. And one of them I discovered just this afternoon, actually, as I was preparing for stream. So we actually need to move the renderer code back out of the material system, I think. And we can either move it into like a K-material render because it's kind of specific to how materials work, or we could just move it to our bespoke renderer. I haven't really decided which one I'm going to do. What I might wind up doing is just move it to sort of our bespoke application renderer, and then if I want to make that generic later, I can move it over to a K-material renderer. But the reason for that is because the material system was never really supposed to actually handle rendering. We moved it out once and had to move it back because of a refactor, and I never actually kicked it back out. So since we're doing a whole bunch of things along those lines, this is one of those things that needs to change because of the way that it accesses data. So we really want the renderer to power how things are, or I should say, we really want the application renderer to power how things are rendered. And the K-material system was sort of stepping out of bounds and sort of handling that for us, which is not ideal. And so we need to take that and move it into our bespoke renderer so that we don't have, the engine sort of maintaining control where it really shouldn't be. Mudbound Dragon raiding with a party of 18. Thank you so much for the raid. I was just in your stream actually, but what all did you get done before you ended? For those of you who aren't following Mudbound Dragon, I highly recommend that you do so. He is working on a Pico 8 base game at the moment that is coming along really nicely, and he actually just finished programming, which is a crazy place to be in. So at this point, it's all about map design and whatnot for him. But yeah, mostly just map design, going to be that for at least a few weeks. Yeah. But that's an awesome place to be in. That's a heck of a milestone. You should be proud. That's super awesome. So yeah, if you're not following him, definitely go do so. Programming's not finished. It's only getting started. Yeah, I know, right? It's going pretty good here. So between last week and this week, we knocked out all of this stuff on my to-do list. So we're basically going through the whole code base right now, and we're tightening things up and reducing how much memory we're using for like handles and stuff like that, and reducing complexity wherever we can. Simplifying APIs, removing stuff that we don't need, all that kind of stuff. So that's just kind of what we're doing at the moment. And we're also transferring control of certain things from the core engine to the application itself. So the two big things there are the renderer, in terms of how things get rendered, and then and that's done, and then the scene itself as well. So what a lot of engines tend to do is they'll give you just this sort of scene with like an entity component system that you just kind of cobble things together in code and configure them using an editor. And that's just kind of the way you work, right? Which is great for like large teams of people and where you really need that for like large scale projects. But like for something like this, where it's mostly just me working on it, or it's going to be for small teams, or I'm not capable of like making all of Unity or Unreal or any of those, right? I just don't have, I'm one dude, right? So for this, for something of this scope, it makes a lot more sense to think about what problem we're actually trying to solve. And unfortunately, what you get with a lot of these large systems that come with being super flexible and super generic is they come with also a lot of overhead. Overhead in terms of code complexity, in terms of runtime overhead, and memory overhead, right? They tend to kind of take up all three. They tend to fragment your memory in a lot of cases if they're not well designed. And so what we're doing here is we're saying, okay, let's pump the brakes on this for a second, because we had a generic solution. We showed how to build one of those if you wanted to do that. And we quickly saw kind of the complexity that goes into that. So let's pump the brakes on that, and let's think about the actual thing that we're trying to solve. So if you think about how a game represents a scene, the needs for that vary greatly depending on the game. So, rendering a top-down game is going to be vastly different than rendering a first-person shooter, which is, again, going to be vastly different from rendering a racing game, which is, again, going to be different from rendering a isometric action RPG, right? All of those have very different needs in how scenes are represented and how those things are rendered. And what part of this whole thing understands what that data is and how it needs to be represented, how it needs to be iterated and organized in memory? The answer to that would be the application code, not the generic engine code, right? And so it's like, well, it's kind of dumb to have the scene and the overall rendering pipeline outside of the front end that translates all the calls to the Vulkan backend and all that stuff. The control of that stuff should not be coming from the engine. The engine should basically say, okay, we're giving these hooks to the application. The application, you do whatever you need to do when it comes time to update, prepare the frame for rendering, render the frame, etc. And so it really makes sense. The application knows what those requirements are, knows how the data needs to be represented and transformed. It makes sense that the application should actually be implementing those things, not the generic engine. So we've pulled all of the sort of generic rendering code, i.e. the render graph, out of the core engine. And we've replaced that with what we call a bespoke application renderer. And so that is powered by and exists in the actual application code that consumes the engine. And we're going to be doing the same thing with the scene. So we're basically we're actually going to rewrite that from the ground up. But we're going to do it different than what we did last time. So we're going to get into that in a minute. But yeah, that's kind of what we're doing at the moment. So we're pretty much caught up, I think. Let me see here. Barely started on sound. Yeah, sound is like a whole other can of worms too. Sound and music, that stuff goes deep. Tell me about it. I'm making exactly what I need for my one game, maybe some tools, and that will help me with that one game. Yeah, exactly. So like when we get ready to write the editor, it's going to be targeted for this game. And there might be generic components that we can pull out of that, like the gizmo, for example, that we've already written. But yeah, for the most part, it's not going to be made generic, at least initially. Okay. So there's a couple of things that we need to do here. We already talked about the material rendering, right? So we need to pull that out. And then we need to move the scene to be game code, game specific. And so I have a couple of ideas on how we're going to tackle this, at least internally. But we're not going to focus too much on the internals right now. What we're actually going to do is we're actually going to flip the script on this and write this from a consumer or a user perspective first. And we're going to define the API by what the actual game code needs. And then we'll worry about the internals of it afterwards. Because that'll allow us to fine tune how things are stored. So the quickest example of this is if we think about the way that our static meshes are rendered, for example, we have the need to split between materials, right? So we basically bind one material and its sort of material specific properties, and then we have the instances of that material that are tied to each individual mesh, and then we render all those meshes, right, with those individual material instances. And so that means that we essentially need to group our meshes by the material that they are drawn with, right, for efficiency purposes. So that's one thing to think about. And then we also have that gets split up into two groups between opaque and transparent because of the order that the application has to draw them in, right? So we need to split that up into those two groups as well. So when we're thinking about how we're going to store this stuff in the scene, instead of just storing a bunch of, a flat array of, a whole bunch of static meshes, we're going to categorize those and store them by material so that it's quickly iterable. And then we can just, when we're going to build our render data for the frame, we can just very quickly blaze through whatever it is that we actually need to process and prepare that as quickly as possible and get on to the actual rendering of it. So that's going to reduce the amount of processing that we have to do to sort of organize things every frame like we're having to do now in our game code. So that is going to drive kind of how things are internally represented, right? We're also going to have like a sort of entity structure, right? But we're not going to have like any sort of component or anything that gets attached to it, right? We're purely going to be dealing with entities in here, and an entity is really nothing more than an index. And that will index into essentially properties. And then, we may have a static mesh entity that has additional properties that sit on top of that, right? So whether that gets organized by us having a array of structures, base entities, or an array of structures, static mesh entities, externally does not matter. That's an internal implementation consideration. So whether we do it this way or whether we have, whether we go structure of arrays, solely depends on how we're going to be querying it and what data we're going to be querying. So we can figure that out after we actually get the API for the scene put out there, right? So this whole replace node with config with entities, remove concept of attachments. I'm actually going to get rid of that because we're actually not going to refactor the existing scene. We're going to write it from the ground up. We do need to remove all references in scenes in the game engine core runtime, right? So these are going to be the things that we're going to work on now, right? This is sort of the last large push. My thought behind this is that we probably can start figuring out the API of what the scene needs to look like in terms of our game code. And that will allow us to say, okay, do we actually need to perform this step? Do we need to perform this step or this step first? Kind of give us an idea of what we need to do where. All right, enough talking. Let's actually take a look at some things here. So we have core resource types. So most of what exists in here is actually having to do with scenes and attachments and stuff. So a lot of this stuff is going to be going bye-bye, right? Almost all of this, actually, which is cool. So and to date, I should mention that we have since we started this sort of refactoring phase, we have about a 3-to-1 ratio in code removed versus code added. So we're actually eliminating a lot of code here, which has been a pretty awesome trend. Okay, so I've started. So we have Illumina scene. And this is where I kind of started thinking about some of the ways that we might represent some of this stuff. Red diffs are so good. Yeah, exactly. Like if I do, actually I could probably just pull one up real quick. I could just diff the branches. Because I did make a bunch of changes over the weekend. So let me see. Let me see what this would wind up being. Okay, it's varied a little bit from that, but here, let me just pull it out in one tab so you guys don't have to see all the tabs I have open. All right, so we have 101 changed files, right? And this is just in the 0.11 branch. So if we come down here, we have 3,500 additions and 8,500 deletions, right? So we're not quite 3-to-1 anymore, but we're not 2-to-1 either. So we've some of these additions have also been without the actual deletions having taken place on some of the other stuff. So the render graph code, for example, I don't think has been completely removed from the testbed library, for example. So there are things in here that have been replaced with the new system, but the old system hasn't been fully removed yet. So I suspect we'll probably wind up going back towards that. But yeah, for the most part, it's mostly red for sure, which is kind of cool. I am a fan. All right. So I wanted to start thinking about, some basic things that we're going to need. So we need, obviously, a scene state, right? So the 3 states that I can think of are uninitialized, where basically the scene itself really, hasn't been created, loaded, anything, right? It's just kind of uninitialized, right? It's not essentially ready to render. And then we have this loading state where we've loaded up the configuration, and we're currently waiting on entities and their resources to load, right? And then loaded means it's ready to go. We can go ahead and render it. So we don't normally start rendering a scene until we actually hit this loaded mark, and that's when we actually render a scene. And so we're going to have state in there for one thing. I started thinking about some entity types that we're going to need, and these are the basic ones that I kind of came up with. So the entity type of none is basically going to be used to essentially group entities together. You can have an entity that really doesn't have any sort of rendering on it or any of that. It just basically represents like a parent transform that could have other stuff childed to it. So there's that. We have static meshes, height map terrains. We have then some ones that don't necessarily get rendered directly, like audio emitters, volumes, point lights. I did not include directional light in here because directional light is not going to wind up being an entity. It's going to be more of a property of a scene. Same with skybox. You'll notice that's not in here either. So that is another one. One that I did miss, though, is I need water plane, because we can have more than one of those. So water planes are another type of entity that we can have. And we'll obviously add to this list as we go. The order of these doesn't really matter either, just kind of what I've come up with so far. So we typed we just forward declared the Illumina scene and frame data, because I don't want to have to include frame data in this H file. And so the Illumina scene will be completely represented internally, and this will essentially be an opaque pointer to the rest of the game code, right? Now, the reason I'm not using an integer or something like that to represent this is because we're not going to have a bunch of scenes loaded and rendering at a time. I'm making the design decision now that we're going to load and render one scene at a time. We could theoretically change that, but we're not going to have so many scenes we need to index them, right? So I think in this case, that's totally fine. So it's going to be an opaque pointer. We're not going to know from the rest of the application what's behind it. That's just kind of going to be the way that exists, right? And now that I actually think about it, this is not going to quite work. What we really ought to do is we probably ought to do struct Illumina scene. Let's just do that, right? Instead of doing the all-out scene thing. Let's actually, because that just kind of makes it really obvious that we need to, since it's an opaque pointer, we do need to dynamically allocate memory for that, right? And using that as a parameter is just kind of weird. So we're going to dynamically create that, and then if it's successful, we'll return 1. If it's not, we'll just return null, and that's what we'll use for our success check. The destroy just takes a pointer to the scene, pretty self-explanatory stuff. Update, again, the stuff you would expect here, pointer to the scene, and then frame data, and you can use that for per frame allocations, using the frame allocator, or game timings, things like that. That all comes from frame data. And then we have just a simple getter here to grab the state of the scene, right? And then here's where I started thinking about how are we going to actually retrieve data from this, right? So I'm thinking bespoke functions for each individual type of data, right? So we have skybox render data. That's pretty straightforward stuff, right? You just say, hey, scene, what skybox do you have? Give me the render data for it. And then this will be a structure that we've already used in our renderer. So this will have all the stuff that it needs in it, where I could just pass it directly over to the renderer and let it do its thing. And then we have get static mesh render data, right? So this is static mesh specific because you'll notice here that this has a material render data in it. And that structure, if you recall from our renderer, is basically a list of geometries to be rendered for a particular material, right? So this is how we split that up. This is how our renderer expects it. We can use this same structure and output to the same structure from the scene, so that way we can pick this up directly and hand it over to our renderer. So the things that it's going to need to know, I think off the top of my head, obviously the scene and frame data. We're going to need a frustum, which we're going to say is optional, because if we don't want to use frustum calling for some reason, we could just pass null here, which we'll probably do while we're still testing it to make sure things work, right? And then we'll hook up frustum calling. We can pass along some flags for it, which we'll get into that in a second, and then we will output a count of materials, right? And then an array of the material render data, right? So this is going to be one of these structures per material that we have represented in the scene. And then each one of these materials obviously will have a list of geometries that will be rendered for it. So we won't have to do a whole bunch of work in our game code as we're doing now to sort of sort these and get this structure. The scene will store it that way and just kind of do it for us. Let's see. Would billboards and UI be its own thing? So billboards are something we do need to add. That's on the to-do list somewhere. So that'll be its own type of entity. UI, though, is its own thing. UI is handled completely separate from this. Yeah, so this is just like a world scene. Thank you for the follow. Appreciate that. Code, good to see you. Rework FreeList to take alignment into account as an optimization or bug fix. You know what? I put that on there a long time ago. I don't think FreeLists directly use alignment. I think they expect if you want Or did I fix that? I don't remember if I fixed that or not. That might wind up being something that, like, I know there's a couple of things in here that I've already fixed and forgot to take off here. So at some point we're going to go through this. But at one point, the free list did not take memory alignment into account. And this was basically just to add an enhancement in there to do that. I think the dynamic allocator actually does it around the free list. I don't think the free list itself does that. I think the dynamic allocator figures out that on its own based off of what this gives it, but I can't remember. Have you considered having a slice type, basically struct, void pointer, and use 64 length? Makes this kind of return much easier. Do you mean... Oh, you mean here? I mean, I could do that, right? It's just this is kind of the pattern I followed everywhere else in the code base. So I don't know if I want to break that. You're not wrong. It'd be nice to sort of, essentially be wrapping this in another structure that says, I have an array of these things and here's how many I have. What was the reason to use opaque handles, and why did you decide to switch them to direct IDs? You mean for the other systems? So for the other systems, we were already kind of doing it that way. It's just we had, we were using these things called K handles, which had a U32 index and a U64 unique ID that was used for stale handle evaluation. But I kind of determined that, like, anytime for basically every system that was using it, I never wound up with stale handles just because it was already just kind of correctly handled, for lack of a better term, within the system to not do that, essentially. So it never wound up actually being a real problem that it had. So instead of passing around that K handle structure everywhere and having to maintain that, I changed it so that each system would have its own type def and then index type based on how many things it could actually have. So some of them use a U32, some of them use a U16. I think one of them even uses a U8. But before that, even with the K handles, they were already essentially using what would amount to an opaque handle. And that's because in most cases, you don't need to pass the entire struct around with all the data. There's a couple reasons for it. That's one of them. So think about a texture, for example, right? A lot of times when you're passing a texture all around for one thing or another, ultimately all you really need is the internal pointer to whatever the backend resource is in that texture, right? So whether it be an OpenGL texture ID or a reference or index to get the Vulkan image ID or whatever it is you're doing, 90% of the time when you're using a texture, that's what you need. You don't always need, the other properties like format and width and height and all that other stuff that you'd have in a struct, right? So you're just passing around this huge struct for absolutely no reason, and pulling all that into memory and blowing out your cache every single time you have to iterate a bunch of them, right? So instead of doing that, for the texture system, for example, I split those things out into a structure of arrays, and then we only actually grab the info that we need to iterate through, right? So that's the reason for that, because it makes it so that all we're doing is passing around a number. We don't have to worry about pointers or anything. We're just passing around a number, and it's a lot easier. So yeah, the reason I'm doing an opaque handle here, though, instead of using an index, is because we're not going to have so many scenes that, it makes sense to actually index them, right? Like, it just doesn't make sense for this particular system. So this particular system is going to use an opaque handle. We'll actually define this internally But it'll also feed into our third big reason for doing this, is it makes internal system refactoring easy. So let's say our texture system only at first was, using type def handles that were a U8 underneath, and we're like, well, we need more than 255 textures, right? So we need to bump it up to a U16. All you'd really have to do is change the type def of the handle type, and bam, your system just works, right? Maybe a couple of other iterators and things like that, but for all intents and purposes, it makes the refactor easy, and it keeps it completely transparent to the rest of the system. This is kind of the same way, right? By not actually passing the actual structure around, in this case, just passing a pointer, right? We don't have to worry about all kinds of other stuff worrying about what's in this structure and potentially breaking code, because any of the data that we need to get from this, we get from here. So the interface point will never change. And thus, if we do change how this is represented internally in the system, the rest of the code is completely oblivious to that. So I hope that makes sense. Came to the same conclusion in my own renderer. Never had stale handles because I was the only one working on the project. So keeping generation info in the handle ended up just being a waste of space, really. Yep, exactly. That's exactly what I came to the conclusion of. I do have a khandle 16, which basically uses a U16 index and a U16 generation. But even that, I don't think I'm going to wind up using. Again, for the same reason. So I think this is way better of a solution. And it makes refactoring easier if I have to add or remove features or whatever and whatnot. So I'm switching basically everything to work that way, either through that or opaque pointers like this. Okay, so back to static mesh render data, right? So for now, I'm going to stick with this. There's only going to be a couple places that actually call this anyways. So if I do wrap this in a structure that also contains the count, cool, but I'm not really that worried about it for now. So we have the scene, frame data, an optional for us. Flags is the next thing I want to talk about, right? So these are organized by material, but there's additional flags that we can pass in. Now, there's only one flag actually defined here. Well, there's two technically, but there's either no flags whatsoever or it's a transparent flag. So the way that this is going to work is if you set this transparent flag when you make this query, it's only going to return geometries with transparent materials. And then if you don't set it, it's only going to return geometry with non-transparent materials because we need that separation in our renderer, so it makes sense to support that here. If for some reason we ever needed to support both, then all that would do is it would just require me adding like a second flag here that maybe says both and just checking for that instead. So this, doing it this way just kind of allows me to switch a bunch of different things as they sort of come up without having a whole bunch of Booleans or something. So this is going to cover our situation for getting geometries for the shadow pass as well as the forward passes, right? Because that's going to split up the way it's going to split up things the way that we need them split for all those different things, right? So this one function is going to handle both of those items, right? And all the places that we call it, which is actually like 6 places, because we have reflection and refraction passes and all that stuff too. But we can pipe all of that through here, which is awesome. The other thing that we need to do is we need to do get terrain chunk render data. And I want to talk a little bit about this because that's going to require a little bit of a new structure. Because I was looking at how we handle this in the renderer, and I'm actually going to pull up the renderer over here. And have HMT. So in our shadow pass, we obviously have the shader for the that's used. Wait a minute. This is, hold on. I don't want to look at this. I want to look at the render data, not the actual. Where was it? Oh, just HM underscore. Okay. So in the shadow pass render data, right, the thing that we have to build to actually perform the shadow pass, obviously we have our opaque geometries, right? So all of our opaque geometries are treated the same way. We don't actually use the material at all. And then we have our transparent materials, and these are for our static meshes. Our terrains are a little bit different, right? So our terrains don't have the concept of opaque versus transparent. We don't support transparency in terrains, so it simplifies that a little bit. The only things we have here for that is the terrain model matrix, which we need to come back to that. A number of terrain chunks, height map terrain chunks, and then the render data for each one of those chunks, right? So the render data is basically what you would expect: vertex and index offsets and counts, right? And that's just already loaded data that's in the buffer. So we have that, and then for the scene pass, right? And this is going to be used for the reflection, refractions, and sort of the standard pass that happens afterwards. We need a little bit more information, right? So we need the material instance, and then we need the terrain model matrix, and then the chunk count and the actual chunks themselves. So realistically, what we would need for both of these is a structure that contains this. However, there is the possibility, there's the distinct possibility that we have more than one terrain in a scene. I don't know that we're going to do that, but I could definitely see it happening. And so we probably need to think about that. So if we want to support more than one terrain, which historically we kind of did but never really used it, then realistically we should have a structure that wraps this, which would also make the terrain model make sense, right? And then gives us a count that sits along that, and an array that sits alongside that, right? And so that's kind of what I'm thinking we really need to do, is take all this. And we're going to have to change our renderer, but it's a good change, I think. I think it's a change that we probably should have made from the get-go. So I'm going to type def struct, and I'm going to do height map terrain render data. And I spelled type def wrong. Always doing that on stream. I don't know why. So we have height map terrain render data. And we're going to paste these properties in there. Right? And I guess we could probably rename these things because we know they're for height map terrains at this point. We could probably just use material instance. We could probably just use model, chunk counts, and chunks, right? So we have that, and then we can then take this bit here, and we can do U32 terrain count, right? And then do HM terrain HM terrain render data. We have an array of those, and we'll just do terrains. Then we can get rid of this, right? And so that's how we'll solve that. And then we also have the scene pass render data, which is going to have the same thing. And then the only difference being is for the shadow pass data, we just won't use the material, right? That's really the only difference there. And then it'll be up to the renderer to sort of figure out and know how to use that. Let's see. It's a cool way to think about it. All these structs remind me of Team Fat Struct from the Better Software Conference. I don't think I've seen that, but Unless you're talking about Casey's discussion of, having a big fat struct for like entities and stuff, which I still haven't gotten all the way through that talk. I need to at some point, but that's neither here nor there. So let me just fix this in the game code real quick, actually, before we do anything else. So we'll do Illumina main first, and we're going to have a few places where this is going to be broken. So we have right now our current sort of scene that we have assumes one terrain, right? So if we have terrain geometry count, what we're going to do here is we're going to say render data, shadow data, and then we'll do terrain count equals 1. And we're still going to need to set up some dynamically generated or some dynamically allocated memory here. But we're using our frame allocator, so it's fast, right? So I'm going to do render data, shadow data, terrains equals, right? And this is going to be HM terrain render data. And reserve with allocator, we're just going to reserve 1 because that's all we actually support. And then we use the frame allocator to set that up, right? I suppose we could just use the frame allocator actually instead of using the D-ray. I suppose we could do that. Let's do that. So let's do frame allocator, and then allocate, and we'll do size of that times 1. Right? And then that's just a little bit cleaner. Okay. So now all we're going to do is, I guess we could index this, right? But that feels like kind of a pain in the ass. So I'm going to take a convenience pointer, and I'm just going to say HM terrain render data. I'll go ter, right? I'll say the address of render data, shadow data, terrains sub-0, right? And here, we'll just do, let's just do that. And then we can remove sort of the prefix here, which is going to just be that. So that takes care of that. And then all we have to do here, and we'll fix this later, right? Because we don't care about this not working right now. We'll fix that when we actually get the queries and stuff written for the new stuff. So let's see, we need terrain chunks. So this is going to be just that, right? So that's that. I'm actually going to copy this block because I have a feeling we're going to need it again. And this is kind of the repetition and stuff that I'm hoping to get rid of with the new scene stuff, right? So all I'm going to do here is instead of shadow data, it's going to be forward data. Did we not actually have... Oh, it needs to be forward data standard pass. That's what it is. Okay. Forward data dot standard pass. Okay. So the same thing there. And then, yeah, that should be good. So we can use that and replace, let's see, we have a little bit of, actually, is this different? No, this is all the same. Okay, so we can actually get rid of this block. So that's solved. And then one last place that we need to do it is, well, actually, I guess it's going to be 2 places. Because we've got one here for the refraction pass data, and then one for the reflection pass. So actually, the refraction pass is actually just Oh, did we not? Oh, right. Okay. So we need to do this kind of the same, I guess the same thing again. Really all I need is this. Right, so we're just going to, again, do WP data. Whoops, wow, wrong thing. WP data. And this is going to be refraction pass. And then, there we go. Okay. And then we'll do HM terrain render data equals, WP data refraction pass terrains sub-zero. And then what we'll do here is instead of accessing this structure directly, we'll just do that. Oops. Okay. And then we'll just wind up doing, let's see, what is that? 11x. And here as well. Oops. Okay, so this is pulling from standard pass. Oh, we probably need to do standard pass. What was it again? Yeah, it should be terrains sub-zero. That's what it needed to be. Okay, so terrains sub-zero. And a terrains sub-zero. Okay. Thank you for the follow. Appreciate that. My OCD is being triggered by the U32 counts not being together in the struct, all that padding, even though the impact is 0 for actual performance. Yeah, I mean, I can always move it around, right? Like, that's another thing that, like, at this point, while I'm still kind of figuring stuff out, I usually don't bother. Like, that's something I usually kind of do later on. Because the problem is like, I've done stuff like that before, and then I wind up changing the structure later and kind of messing it up anyways. So thank you guys for the follows. I appreciate that. Casey talked about oop. Yeah, that one. Spoiler alert. Yep. Yeah. So yeah, I think I know the direction he was going in that talk. I just didn't quite get there in it yet. I've gotten like maybe a third through the video. Unrelated, and maybe a bit stupid question. Do you guys create separate pools for bindless textures? Asking cause VK descriptor set layout, create, update after bind, pool bit extension can't be cheap when you don't need it. So I'm not actually doing bindless in this engine at all. So my answer is no, because I'm not doing it. But somebody in chat might have an opinion on that. Easy. Yeah, exactly, Soulfoam. Exactly. How are you doing, by the way, buddy? Good to see you. Okay, I'm going to take all of this time. All right, so I just need to do the same thing here, except this has to be reflection pass. Let's see though. I don't feel like that's 100% correct though. So we allocate the array. We do this, which that is actually going to be correct. What is... No, that's fine. Okay. So this just needs to be, instead of this... Oops. Keep hitting the wrong keys. All right. So this just needs to be that. And then this is just going to be right. Okay. Yeah, this needs to be reflection pass terrains sub-zero. Which I guess I could have just used whatever. This is temporary code anyways. I just need it to work for now. We're going to be refactoring all that stuff anyway, so I just needed to patch it and get it working. I don't really care about how it's organized at the moment because it's all going to be going away. It's just to keep things building in the meantime. Do you have a GitHub, and also, and if so, does it have your dot files? So it has some of them. What I will do is... so the GitHub for this can be found by going to that link. This is sort of the central hub for the website, and if you come down here, there's a GitHub link. You click that, and it'll take you to that repo. If you're looking for like my dot files for NeoVim and stuff, that link right there will take you to this page where I basically go over all of the setup that I'm using, and I have a GitHub repo with my NeoVim config in it. So I hope that's what you're looking for. But yeah, I basically wrote up an article of like all the stuff that I use and why. And I actually just updated this too, so it should work. I haven't tried it on the bare bones install yet, but it should all be up to date and work. Thank you for the follows. Appreciate that. Descriptor pools are most likely just an array that holds enough space for each descriptor type, so updating this is not a problem at all. The reason why they didn't ship with that by default because of synchronization, not performance. Yeah, you're probably right on that. Recently moved to descriptor buffers, so I handle all of that myself. Yeah, I haven't done that either. Thank you for the stretch redeem. Appreciate that. Ooh, I needed that too. Okay. All right. So that's all we need to do for terrain data. So now what we're going to be doing to sort of get back to what we were doing before. Oh, you know what? I didn't update. Did I update the renderer? No, I did not. It's not going to be a big deal though. So this is rendering different terrains. So let's see, do we need to... This is to draw each terrain chunk. This is in the shadow map tech shader. So we have our cascade. That doesn't need to change. This is each terrain chunk, but it's not... It doesn't take into account multiple terrains. So I'm actually going to rename this variable to, oops. I'm going to rename this to C for chunk. And we need to do one more loop outside of this. So we're going to say for U32 I equals 0. I is less than render data, shadow data, terrain count. plus plus I. And we're going to wrap this whole thing in there. And then this is going to get its terrain chunk count and stuff from that actual terrain. So we're going to say HM terrain render data. We'll say T equals the address of render data, shadow data, terrains, sub I. And then here, instead of render data, shadow data, we could just do T. And then chunk counts. And then we can do T chunks. And then looks like there's one more thing in here. The terrain model, right? So this is going to be, instead of this, it's going to be T model, right? And the shadow map does not use the material, so we don't really have to do anything there. So that's all that is, just sort of adding another loop so that we can support multiple terrains. I guess that's it for now. I guess the material system, do we actually have that hooked up in here? Scene pass. Oh, did we not even hook up terrains in this at all? We might not have. We might not have. Yeah, I don't think we did. All right, well, it's not that big of a deal because we don't have blended materials anyways to render it, so I'm not going to worry about it for right now. We'll come back to that when we're ready to fix terrains. Okay, so I guess actually we could probably just kill this buffer for the time being, but let me not do that. I might need one of these over here. All right. Heck with it. So you can see what we're doing. Okay, so Illumina. Oh, I just called this HM terrain render data. It's kind of inconsistent on the naming. I'll refactor it later. Illumina scene get terrain. I guess it should be HM terrain render data. So it's going to need some of these same properties. So I'm actually just going to take all of these. And we're going to do out terrain count. Right? So we're going to have an array of render datas. And then flag bits, I don't think actually makes sense here. So what I'm going to do is, instead of using a specific type for this, I'm just going to put U32, and we're just not going to use it for now. The reason I'm doing that is so that if we do add flags to it later, we could just very easily pipe those in and not have to worry about, refactoring it. Worst case scenario, we have an extra parameter that we don't ever use, but I'm not that worried about it. Potham, good to see you. How are you doing? Just read up about nested functions in GCC, and they seem like a good idea at first, but how they are implemented is very bad. They use the executable stack. Yeah, that just sounds like something that was a good idea in theory, but in practical or in application, it's just not great. Dingus-oriented programming was strong with me today. I was doing some fancy calculations to get something to work, and my buddy looked at my code, face-palmed, and told me to use the modulus operator. That sounds like Dingus-oriented programming for sure. I appreciate you telling me, though. This is the home of Dingus-oriented programming. It's what we do around here. Nested functions are not it. Yeah, I tend to agree. Yeah, I've never really been a fan of that. To me, it makes the code a little harder to read, actually, in most cases. Okay, so that is our terrain render data. So we have something for Skybox, something for our static meshes, and something for our terrain render data. And this contains material information that we'll already need. Contains, yeah, I think that's all we need. So let's see. The next thing that we're going to need is debug render data, because we need a way to actually get that out, right? And thankfully, that doesn't have to be broken up by material or anything. That is just debug geometry render data, right? That's literally all it is. So we'll say Illumina scene get debug render data, right? And we will probably just use these same properties again, right? We've got some consistency here. And yeah, we'll take the scene frame data, frustum if we want to cull, and then flags, and then out geometry count. So as far as querying things, that is basically the way that this stuff is going to work in general, right? There is one more thing. Let's see. We have forward pass water plane render data. That might not be the structure we want to use for that, but we also need to query for water planes, right? So Illumina scene get water plane render data. I'll put this in here for now. Again, kind of the same thing here. Right. Let me see what this has in it. Model, offsets. Yeah, see, this is the stuff I don't necessarily want to include. Okay. Because this kind of stuff we actually build, we do need to build this in the application, right? So we actually... we probably ought to have a different structure for this. Let's do this instead. Let's do typedef struct Illumina water plane render data. Right, and in that, in that, we're going to have this stuff, right? And then here, we'll actually just have Illumina water plane render data. And we'll just use that there instead, right? That makes a little bit more sense to me, because then we can use this structure to actually query. And then this is what we pass to the renderer, right? So we'll do that, which makes a lot more sense, I think. Okay, so if we take a look at our entity types here, we have static mesh, height map terrain, audio emitter, we don't render that visually. Volume, we don't render that visually, nor a point light, and then a water plane we do. So I suppose we could probably just move maybe the stuff we visually render together, right? And then these three things are actually visually represented by debug data if that type of enabling is on, right? Which is kind of another thing that we should talk about, because there are several things that options and stuff that we're going to want to toggle on and off for a scene. So we probably ought to have some way to toggle those things. Let's see, updates. Okay, so we have the scene state get here. So let's do let's do the ability to toggle off and on debug geometry, right? So one thing though is we should only be able to do this in a debug build, right? So if Kohi debug, right, and then we can do here let me think, how do we want to do? I guess we could just use booleans. I was thinking like we could set flags, right? But like flags, we could really just represent that internally with flags. But from a user interface perspective or like game code, it might be easier to just be able to say true or false, right? So let's do void, turn type void, and we'll do Illumina scene enable debug. So struct Illumina scene, and then B8 enabled. Right, so we could very easily say, true or false for that. Do we need a getter for this? I don't think so. I don't think the renderer needs to provide that. I think we can just toggle it on or off. The other thing that I was thinking about that might be nice to be able to turn on or off is to enable or disable the debug grid, because that is something that is definitely something that kind of gets in the way sometimes, but other times it's nice to have it on. The other thing we should do is put this guy in the debug as well, right? So we're only going to actually have that enabled if we're actually doing a debug build. There is one more thing, which is Illumina editor gizmo pass render data. What does that actually have in it? What does that actually have in it? Let me see. Okay, so this is kind of another one of those situations where we probably ought to like wrap this in a different structure. World debug pass render data. Kind of like what we did with this. This technically is just debug geometry though. So actually we just really need a second call for this. Okay. So instead of using the gizmo directly at that type instead, we can actually just copy this. And say get debug. I guess instead of debug, it's going to be, yeah. That's really long. Let's get rid of debug. All right. However, so this is to render our editor gizmo. We're not going to have multiples of those. We're only going to have one. So we actually don't need this geometry count, right? Because we only have one. Okay. So I think that is kind of what the interface is going to look like, right? I want to keep it as simple as possible, and I think this is pretty simple. I suppose we could have a look at. The existing scene H file and see if we have anything else. Let's see. We have update LOD view from view position. I feel like that's something that should be internally done. That's essentially something that tells the scene where the camera is, the view camera is, and then it uses that to update the terrain's LODs internally, so we know which one to actually render based off of camera distance. I suppose I don't need to implement that right away. We could always add that later. But what we could do is when we update, we could add something to the update. Right, where we say, how do we want to do this? We could have camera transform, which we could extract everything from that. Or we could just pass position and I guess position and rotation and maybe direction. I don't know. We'll start with position, I guess. So vec3 camera position. And I don't even know that we should actually be passing it here. I feel like we should probably actually set. Maybe we should just set the current camera. Oops. Yeah, I think we're going to set the. I think we're going to set the camera. Which, speaking of which, the camera system was the type that was indexed by U8. By the way, couldn't remember which one it was. So we'll just pass through a K camera. Let's do. And obviously I'm going to comment all this stuff later. I'm just kind of trying to figure out what the interface should look like for now. So let's do void Illumina scene set active camera, right? And we'll do struct Illumina scene K camera. Right, and we'll just track that internally. And the nice part about doing that is then we can query the camera system for any of the data that we need as we need it, and we don't have to resort to stuff like this having to be called from game code. We could just kind of handle that internally. So we can get rid of that. Let's actually go all the way up here. I don't want to look at any of the structure stuff because that's all going to be changing and going away. So we have create, initialize, load, unload. Okay, so part of what we're going to be doing with simplifying this interface as well is I don't want all these steps, right? They're not really necessary. I had split them up because I was thinking of, maybe just loading up all scene configurations, but not like loading the actual thing. But I don't think that's, again, I don't think it's necessary. So what we're going to do instead is we are going to file create, initialize, and load. Everything that those were doing is going to be now done when we create, right? So this is going to create the scene and kick off the loading process. And then destroy is going to unload it and destroy it. We're not going to have a separate unload. We're just going to destroy it, right? And as soon as this is called, we'll flip this state over to uninitialized, and then, commence unloading the scene. So that takes care of that. So we don't have a separate unload and destroy like the old system did. We have updates. We do have render frame prepare. Now that is a hook that we might actually need. So I'm going to put that in here. And if we don't need it, we can get rid of it. So that is a separate step outside of the update loop that is done just before actually drawing a frame. So the update loop and frame prepare are not necessarily always just called within the same frame, right? They are technically different parts of the life cycle. The update is essentially a fixed time call, right? So update, I think right now is set to happen 60 times a frame. Whereas frame prepare, if we have an unlocked frame rate, can be called many, many more times than that, right? As many times as the actual renderer will allow. And so that's why these two things are split into separate steps, right? So we perform any sort of world or state update here, but like anything that we would need to prepare for rendering would have to be done here. I don't think we're going to need this. But there we are. Okay. Let's see. Let me catch up on chat here. Oh, you guys are talking about synchronization still. Okay. First time chat. You don't really get much help from your tab completions. Yeah, I mean, sometimes I do, sometimes I don't. Like sometimes if it's really long, I will, or if I forget the name of something, then I'll get some help by it. Or sometimes what I'll do is like, if I know basically what something is called and I don't want to type out Illumina scene frame prepare, I'll just type out, ISFP, and it'll just kind of give me that option. I can hit enter. But sometimes I'm just typing along too fast to actually even think about it. So sometimes I use it, sometimes I don't. Let's see. Why do you use in code base types lower than 4-byte like B8 or U16 for the logic part, like return value or function argument, since 4 or 8-byte integers are native for CPU and B8 takes more instructions than B32? Well, because you don't need to store, I always assume these things are going to be stored somewhere, right? They may or may not be, right? Depends. But in a lot of cases, the stuff that we return is the stuff that we store. So I don't want to store a B32 just for a single Boolean, right? I'd rather, if I have to have a Boolean somewhere and it can't be flags, I'd rather just use a B8 for that. Yeah, it's more about conserving memory, I guess, at that point. Unless it's an struct and it's not packed correctly. But I'm really not optimizing for things like that yet. I'm not there yet. At some point I will be. I'm not there yet. It's funny that on Linux build time is faster than on Windows. What a good reason to use Linux. Yeah, it's extremely, there's a huge difference. And it was because of the way that Clang CL works on Windows and the way that it reads from the file system. It's lightning fast on Linux, but it takes forever, comparatively speaking, on Windows. It's really annoying. It makes me consider using a Unity build because it's that annoying. What's your Vim settings like? So I will give you a link. Assuming my bot is working over there on the YouTube side. Is it going to work? There it goes. So that link will take you to an article that I wrote up about my NeoVim setup, which I just recently updated. And that has a link in it to my actual dot files for my NeoVim. Yep, no problem. Let's see. Wayland's been giving me so much trouble. They do some really weird stuff. Now, are you targeting Wayland in your code, or are you just targeting X and using X Wayland? Or do you just mean in general using it? You were trying to? Yeah, that's on my to-do list. I'm making use of X Wayland right now. I'm running on Wayland at the moment. And it's been great, but yeah, I have to write a Wayland layer at some point. I'm not looking forward to it. I like the desktop environment experience using Wayland, but yeah. All right. Although it can't possibly be any worse than writing all the windowing stuff in X11. That was kind of terrible. And all the different ways to do that. And some of the antiquated, terrible ways of doing it, and the way that it handles memory in some cases and all that. Yeah, can't be much worse than that. Okay, so let's see. What else do we have in here? Oh, scene raycast. I completely forgot about that. Okay. So this is something that we really do need to actually do, right? Is obviously we need to be able to raycast into the scene. That's important for like object picking and who knows what else. So that one I probably am just going to keep mostly the same, except no, I'm going to keep it exactly the same. Actually, I'm just going to copy this over here. So I'm going to do Illumina scene raycast. And then this is going to be Illumina scene. Struct, of course. And then why did I use the ray? Isn't that in math types? Geometry 3D. Yeah, I guess I can do that too. I'm actually going to take these and move them up here, because they're kind of hard to spot in there. All right. So we have the raycast. Let's see, what else do we need? We also need the raycast result. Oh, I should have copied that too. So we need that. All right, so that is pretty good. All we're going to do here is, just your standard raycast. I would imagine we're probably going to be able to just rip that logic right out and reuse it. So that's cool. Let's see. So we have all of that. Here's all the queries that we have. Now, one thing I think I am going to do away with is the query from line, right? Where we had a line that was sort of defined in space, where you gave a direction, a center, a radius. And you queried based off of that. I don't think I'm going to do that this time around. I think I did that because frustum culling wasn't working in the shadow pass. And so the shadow pass was using this. I think I'm going to spend the time and actually get the frustum culling to work properly when we get there. Okay, so we have terrain render data. We've got that water plane. Okay, so transforms. This is something. So actually, this is all node stuff, right? So, which is we're not going to have anymore. So we also have the capability to get the transform of something, or get the transformation matrix from something by name, or by a handle to that thing. I don't think we need to necessarily keep all of this. We also have exists by name, get child count, child name by index. Okay. So some of this stuff we can keep, all right? Not all of it, though, I don't think. So we need a couple things to be able to query into the scene for specific stuff. We do need, let's see. Since we're actually using handles now, let's do another. Let's actually just use Illumina entity, I guess, for that. Let's do Illumina entity, right? And we'll say Illumina scene, and we'll say get entity by name. And all this is going to do is take in struct Illumina scene, and then a kname, name. And essentially what this will do is it'll just return this Illumina entity invalid if it doesn't find it, right? So there's no need to use a Boolean here. We can just actually just use that and then check its return value. So that makes a little bit more sense, right? So we have the ability to get the entity by name. And I think that's the only thing that we're actually going to allow you to get by name, is just get the entity. Everything else in here is going to go by that entity handle. So if you don't already have one, you'll need to get that before you can actually do anything else. Which I think is reasonable. So the next thing is going to be, I think a lot of the getters after this will probably be some form of I don't know if we're going to wrap all this stuff in Boolean checks or not. Kind of like we did here, right? Like this is very defensive code, which is fine. But I think when you're shipping something, you don't necessarily want all this checking to constantly be happening. So I feel like if we're going to get the transform on something, we'll do kTransform. And we'll do Illumina scene get entity transform, right? Struct Illumina scene, and then we'll do Illumina entity, right? And that'll just get the transform from that. And from that, if we wanted to, we could also get the local matrix. We could get the local matrix or the world matrix, I suppose. Even though we don't necessarily have that here. Although I feel like the transform should probably give us that instead of the scene having to worry about it. So maybe I won't use that. Let's see, transform gets. So maybe I will skip these guys for now. Exists. This is basically just a check by name. So we can essentially just do this to see if that exists or not. So I'm not really worried about that. Okay, so these two are important. So child count get, and we have name get by index. What is that? Oh, literally returns the child name. Okay, I don't think we need to do that either. What we can do though, and maybe we ought to put this one right up here above it actually. So we'll do a kname, and we'll say scene get entity name, right? And we'll just get the name that way. And then also, we'll do child count, which I feel like a U16 will probably be enough for that. We'll do entity child count, right? And then we'll do Illumina entity, and we'll do entity get child at, right? And this will be the parent entity and then U16 index, right? So that'll get the child at that index. So this will give you a way to loop through entities without having to create like a dynamic array of them, right? I suppose we could do that as well, right? Provide that utility, but I don't think we're going to need it. This is not something that we're going to have to be doing a lot of. This is basically something you should do once and then hold on to the handles as you need them. Um, all right. Okay, so the other thing is, we have this scene save here is kind of the last thing. And that is something that we haven't really discussed how that's going to work with this sort of this refactor, right? So saving is something that we would only ever want to allow, I guess, on a debug build, right? But there, like, maybe there's other potential times that we want to allow that other than just debug builds, right? Maybe there's I don't know, maybe we want to have a level editor in release build, right? We want to use a release build to actually test it, but like as far as level editing goes, maybe we should, I don't know. I feel like maybe both of these things ought to be tied to that kind of same similar thing, but maybe we just allow it only for debug builds for now. If we want to get a little bit more granular with it later, we can. So what I'm going to do is a B8, and I'll do Lumina scene save. And this is just going to take struct Illumina scene scene. And that's just going to allow us to, write that scene to disk. Okay. I think that's our entire interface, at least for now. We're obviously going to need to add a lot to this, as we want to retrieve more properties from the actual, as we want to retrieve more properties from, the entities themselves. Oh, I know one more thing. We have entity get name. We also need to do Illumina entity type. We need to be able to get the type. Right. So we need that as well. Okay. All right. Yeah, this will work for now. This should give us enough to go off of to essentially replace what we're destroying here. And again, I'm not going to bother with comments and stuff until we actually get all of this straightened out, because I don't want to have to keep updating those over and over again. So now we need to actually start thinking about how we're actually going to piece this together when it comes to the implementation, right? Did I actually wind up? I didn't actually wind up using this thing. We'll just throw that out and pretend we didn't see it. Okay. Let's see. Everything else in here I think is all stuff we're going to use. So that's good. Let's actually move. Nope, I guess that's fine where it is. Okay, so let's take all of this all the way down here. And let's go to Illumina CNC. Obviously, first we're going to have to include Illumina CNH, and we're going to paste all these guys in here. And we're essentially going to, we are essentially going to have to do that. So I should be able to just do, oops, if I can type the right thing here. Oh, that was part of my macro. I screwed up my macro. All right. Let me try that again. Okay, there we go. That's what I wanted. I don't use macros very much, but I probably should be. There we go. Let's see, how many more times do I need to run this? Like, I don't know, 10? No, that didn't work. I was afraid of that. Okay. Wasn't sure that was going to work. Because I didn't record the... I didn't record the next as part of it. There we go. Okay. So, now that we have all of those, let's start thinking about what the actual structure is going to look like. So we're going to do type def, struct, Illumina scene. And now we need to think about, the data that's going to be in here in the actual scene. Right? So, before we talk about that, I want to talk about entities. And I think the first way I'm going to set this up is going to be the most obvious. But I think the nice part about this is going to be if we decide to refactor this later, it'll be really straightforward to do, and it'll be internal to this only, right? Nothing outside of this that uses it will care. So I'm thinking we have internally a structure that we'll call, I guess, base entity. Right? And base entity will have things like k-transform for one. Right? It'll have that. It may have other various properties with it. Let's see. I guess I don't want to include name here, and I'll get into the reason why in a minute. Let's see. Should we do... I guess we could do a... Let's do an Illumina entity ID. Transform. And this will essentially be used to verify like empty slots versus non-empty slots. I don't know that I want to do that though. I don't want to do that. We need entity type for one thing. That needs to be the first. So K or Illumina entity type. We need that. But more importantly, we actually need specific entity types, right? So we have this, which is sort of our base, and then we're going to use one level of, and I use this term loosely, inheritance. So we'll say type def struct, and then we're going to do static mesh entity, right? And in here, the first member of it will always be base, right? So we'll have base entity base. And what this will give us is actually twofold, right? Because this is the first member, we can actually cold cast any of these to a base entity to get its base properties, right? If we wanted to, if we didn't want to do .base or whatever, we wanted to operate on all things, base entity. But also, since the type is the first member of base entity, then that means you can also cast this straight to Illumina entity type. And so by casting that directly to that, you'll have the ability to reverse look up its type. And so in here we might have other properties. Let's go to let's go to the original scene here, because we have down here, let's see, where is the static meshes? So we have this static mesh instance, this K static mesh instance from the static mesh system that we store, right? So we'll need to use that, for example. Right, so we'll just call that mesh. And the static mesh instance itself has an instance ID and a K-static mesh, right? And if you go into that K-static mesh, it's also type def that way, right? So we've got that, and then an identifier of the instance, right? So that should give us everything I think that we need on that. Let's see, what do we have in the metadata for static meshes? I don't think it was anything too important. It was just resource and package name, which I guess is what we would need to write back out to. We would need these to write back out to the scene file. So I'm actually going to take those and I'm going to put them here. And I'll just put under here metadata for serialization later, right? And so I guess you could argue that we probably don't need to store this along with the static mesh entity, whatever. We can figure that out later. For now, I'm just going to group the data together, and we can worry about it. Later. So, when we think about how we need to store something like a static mesh versus other types of entities, like a point light or something like that. Point lights, actually, I think point lights, let's see, here we go. So point lights just has, this kind of stuff in it, right? So it has, name generation, which again, we don't need to store that. Point light data would go there. So, as an example of what that might look like, if we do a type def struct point light entity, right? That is basically going to have this as well, right? And then we'll also have these other properties, right? So we'll have positional offset from whatever this may be attached to. Do we really want to do that? Or do we want to just use... I don't think we're going to do this anymore. I think we're just going to use the transform of that entity to determine the light's position. I think that's fair. But what we do want to do is we have this point light data that needs to be stored, right? And so this is actually what winds up getting fed directly to the shader. So we do actually want to keep this in here. So actually all we really need is just... I guess we could just say data. We'll include light system for now. I want to get rid of the light system, but for now we'll include it. I suppose we could keep those things separately, right? Instead of relying on this structure, but I digress. So that's kind of the way that this is going to work. So we don't have any resource or package name for this. This actually shouldn't be resource name. This should be asset name. We don't have resources anymore. Okay, so if we think about how we're going to be querying things out of this scene, this will give us some indication of how we actually need to store some of this data, right? So if we think about static mesh, right, the way that we're going to be querying this out of here is by material. And for each material, we've got the material itself, and then a set number of geometries that are underneath that material. So it makes sense if we think about it. That we would also internally in the scene store our static mesh entities in relation to the material that is associated with them, right? So there's a couple ways that we could do this. We could set up a structure that wraps this, that then has a similar kind of thing where we have a material and then a list of these, right? I don't think that's necessarily going to be optimal. I think the way to do this is probably going to wind up being we have like some sort of lookup table is going to be the way that we're going to handle that. Let me see. TCAP rating with a party of 15. Thank you so much for the raid, man. How are you doing? What's happening, TCAP? Good to see you, man. What are you working on your stream? Thank you so much for the raid. Really appreciate that. If you guys aren't following TCAP, definitely go do it. He's always working on cool stuff on his channel. He kind of bounces around a lot though, so I'm not sure. What are you working on at the moment? Because you're always working on different kind of cool experimental things. All right. While he's typing that out, so one thing that we should probably immediately do is we should separate these by type, right? So we can have like I hesitate to use a D array, but I feel like that might be the right way to go about this. So maybe we have base entity, right? Base, do we want to say entities? Or maybe just entities, right? So this is going to be base entities with no type, right? And then we'll have static mesh entities. I feel like that's kind of long. Maybe just static meshes, right? And then we would automatically have that separation, right? I probably won't maintain a separate count. I'll probably do a D array so that we have the count with it, and then we can add and remove from it as necessary. Been working on my main game lately, but now I just joined the GMTK jam. Okay. GMTK jam. I'm not familiar with that jam, I guess. I assume it's a game jam. But I'm not familiar with that particular one. Oh, Game Maker's Toolkit. Oh, okay. I'm bad with acronyms, which is hilarious because I use them all day, every day for work, but does a game jam every year. Okay. Yeah, I maybe one of these years I'll check that out. Once this engine's to the point where I can actually quickly make games with it, maybe I'll join one of those. If I get the time, that is. That's the other thing. But that's cool, man. Yeah, I'll have to stop by and check out to see what your progress in your game's looking like. Last time I saw it, it was looking pretty dope, but okay. So if we split them up like this, right? Then we have contiguous arrays of each entity by type, right? So we'll have another one down here that's point light entities. We could say point lights, etc. Right? One of these per type, right? The issue with this is we then need some sort of way to look these up quickly. And the problem with this is what you really want to end up with is a lookup into the appropriate array, right? So the problem is you can have right now, you can have like an index 0 and an index 1 of entities, and an index 0 or an index 1 of static meshes, an index 0 and index 1 of point lights, right? And so we need some sort of way to say, okay, we have a list of global entity IDs. And within that entity ID, we have a type, right? And this is actually kind of what I was alluding to. Somebody else mentioned this in chat earlier, where I think I'm going to wind up changing the actual K entity, right? So I think, or the Illumina entity, right? So the Illumina entity is actually going to wind up being a U64. And what we're going to do is we are going to pack the entity type in as part of that ID, right? So actually, I guess we should probably put the specifications for it here, just so we can start thinking about how this should actually work. Because what we don't want to do is we don't want to have like tons of lookups in different tables and stuff like that, and lots of indirection, right? So we're going to say an identifier for an entity within a scene, and we'll put in here memory layout. And so we'll say, I guess we'll do this by bytes, right? So I guess we'll do we'll do it by bits. Keep it consistent, right? So the first thing we're going to have is we'll have a U16. That's the actual global entity ID, right? And then inside of that, or after that, I should say, we'll have a U8 that's going to represent the entity type. And I don't actually even know if we need this. So I'm kind of thinking this out now as we're kind of going through it. So we'll essentially grab this and convert it to the entity type, which is an extremely short list of types, right? So I don't think this is ever going to go beyond 256, right? So we'll grab the entity type out of there next. Then we'll grab another U16 out of here, and we'll say that this is the entity type index, right? Or index into the type specific array, right? So we'll pack these things in there. And that probably should be a U16 because I can see there being a lot of one type or the other, right? This probably... Do we need, I'm trying to think if we need a global entity ID or if these two things would be enough. Because this will tell us which array to look in. This will tell us what that index is for that array. And we actually still have space left over after this. So I could even like waste space here and say 16, right? And we still have another U16 we can use for something else. I guess that's fine, right? Technically, I could stick with a U32 if I didn't have this. I'm just trying to think if there's any... You might be looking for an archetype for the entity. Yeah, I'm trying to avoid the whole archetype thing, though. At least if you plan to have entities with multiple types. So that's the thing. I don't think I'm going to do that, right? I think one entity is going to be one type. I want to keep it simple, right? That's the whole theme here, is to kind of try to keep it simple. So that just means if you have to create another entity, like if you want to hook two static meshes to something, you just have to create two entities. I don't think that's that big of a deal. Because the other way of doing it, the typical ECS way to do it, would be that you create one entity with two attachments, right? Or two components on it, right? Static mesh can be an audio emitter? No. Nope. If you want an audio emitter, it's a different entity. I feel like we just have one entity as one type, and that's it. I don't see any reason to do anything beyond that. So I don't know that I need this global ID. But I'll keep it there because it'll give me, well, I'm really not thinking I need it though. Because I actually can't think of a use case where I need it, right? Because really all I need is these two. The type of entity I'm dealing with and the index into that array. To encode the index into the global entity array. There is no global entity array. So that's the other thing. This is just for base entities with no type, which is its own type of entity. It's not like a downcast version of all of these guys. It's not that at all. It's literally entities with their type set to type none. And so in this case, like it's like if you wanted an entity to purely function as a parent, to have two other entities as children below it, without it actually having any properties of its own other than a transform, that's what you would use that for. This is a handle specific for that system. Yeah, it is. It's a handle specific for the system. Yep. Which is why I'm saying, like, I don't think I need the global entity ID. I think I can get away with these two. Just entity type and type index. And literally stick with a U32. You'll have n arrays where n is the number of types. Yeah, exactly. So I'll just have, like, literally, this would be 0 for a type of none. It'd be 1 for a type of static mesh, or whatever this happens to be, right? And we can set that up in code, and that's really easy. All right, yeah. I'm just gonna do it this way. The nice thing about setting it up this way is if the internal representation has to change, or I have to expand it or include more data in here for some reason, I can do that, and all the implementation details are completely left out of everywhere else. So yeah, I literally think this is probably going to be the way to do it. It's just a packed integer. Because I literally cannot think of a use case where I need a global identifier of any kind. These two together make the global identifier. Because you'll only ever have one combination of each of these things. Makes sense to me. All right. And neither one of those combinations will ever equal this. Well, okay. Neither one of those combinations will ever equal that. Because we'll never have, the enum will never go that high. So theoretically, you know, this could still just be a U8. Or even less, technically. Handles are great, yeah, they really are. And I like this implementation of it even better. than the actual explicit K handle thing I came up with earlier on. I think this is way better. Yeah, okay. I'm pretty happy with that. So this automatically just allows me to avoid having to do like lots of cross lookups. And then as far as the name goes, the name I can use like a BST that points to one of these. And so the names can be kept separate as well. I like it. Like it a lot. Cool. All right. So that's as far as we're going to get tonight. I know it was kind of a lot of theory and a lot of kind of talking through design stuff, but sometimes that's the way it goes, right? So in the next stream, we are definitely going to pick up and we're going to write some more code having to do with this. We're going to start filling some of this stuff out, making use of our handles and actually setting up what our entities are going to look like and start hooking up all that stuff. So, all right. Let's see. So I think that is going to do it for tonight. Let me go ahead and find somebody to raid. While I do that, I do just want to say a quick thank you to everybody for participating and being here and hanging out with me and following me along on this long journey. I appreciate you guys being here. If you haven't already, I would greatly appreciate a follow either on the YouTube side or the Twitch side. Or if you're so inclined, both. I would greatly appreciate that. I'm definitely trying to grow my channel, and the whole point behind doing this is to motivate people to want to get into this sort of lower level development, because I don't think we have enough competition, especially in the game engine space. And I think that competition is what drives ingenuity. And so if I can help at all in making that happen, or at least motivating people to make that happen, then awesome. I consider that a success. So I'm just really quickly looking for somebody to raid. Hopefully that's doing something kind of similar. What's hilarious, TCAP, is I was actually thinking of raiding you if you were still on, but that's the way it goes sometimes, I guess. Let me see. All right, well, I see somebody doing a GMTK game jam, so maybe that's who will raid. Let me just see who else is online really quickly before I move on. Bear with me just a second. Okay. Yeah, I think that's what we're going to do. Where'd they go? Here it is. Okay, this is somebody I haven't raided before, so we're gonna see what they're up to. At Egon Dev, I assume is how you pronounce that. We're gonna raid them, see what they're up to. And yeah, again, thank you guys so much for being here. And I will catch you guys on the next stream, which will be tomorrow night around the same time. So I'll see you guys then. Thank you so much. And yeah, see you guys then.